So since we are on the topic of global change and itself in Alaska, in the northern Arctic part of Alaska, over the last 30 years or so, temperature has increased about half of a degree Celsius per decade. And scientists have noticed that there have been changes in surface vegetation during this time. Shrubs are increasing in the tundra. Tundra is a flat land with very little vegetation. Just a few species of plant grow there because of the very and not permits and because of the cold temperature of the tundra two layers. And the tundra is frozen in the winter and in the spring, but so in the summer. Beneath this active layer is a second layer called permafrost, which is frozen all year round and is impermeable to water. So, because of the permafrost, none of the plants that grow there can have been counted. No, and that's one of the reasons that shrubs survive in the Arctic. Shrubs are little bushes. They are not tall and they grow in the cold and wind. And there's road growth, so the permafrost doesn't interfere with their growth, okay? Now, since the temperatures have increased in Alaska, the growth of shrubs has increased. And this is presented to climate scientists with a puzzle. Oh, I'm sorry, when you say the growth of the shrubs has increased, do you mean the shrubs are bigger or there are more shrubs? Good question, and the answer is both. The size of the shrub has increased, and the shrub cover has spread to what was previously shrub-free tundra. Okay, so what's the puzzle? Warmer temperatures should lead to increased vegetation growth, right? Well, the connections are not so simple. The temperature increase has occurred during the winter and spring, and not during the summer. While the increase in shrub has occurred in the summer. So how can increased temperatures in the winter and spring result in increased shrub growth in the summer? Well, it may be biological processes that occur in the soil in the winter that cause increased shrub growth in the summer. And here's how. There are microbes, microscopic organisms that live in the soil. These microbes enable the soil to have more nitrogen, which plants need to live, and they remain quite active during the winter. There are two reasons for this. First, they live in the active layer, which, remember, contains water that doesn't penetrate the permafrost. Second, most of the precipitation in the Arctic is a form of snow, and the snow which blankets the ground in the winter actually has an insulating effect and warm enough for migrants to remain active. So there's been increase in nutrient production in the winter, and that was responsible for the growth in the summer and spread in the news through the tundra areas with more nutrients as the areas with the racism shrub. Runoff in the spring when the snow finally melts, so once the nutrients get washed away, spring so always wash away soil, doesn't it? Well, much of the soil is usually still frozen during peak runoff, and the nutrients are deep down in the active layer anyway, not high up near the soil, which is the part of the active layer most affected by runoff. But, as I was about to say, there's more to the story. The tundra is windy, and the snow is blown across the and we were so that extra ones means even more microbial activity, which means even more food for the shrubs, which means even more shrubs and more snow around, etc. It's a cycle, a loop. And because of this loop, which is promoted by warmer temperature in the winter and spring, well, it looks like the tundra may be turning into shrubland. But will it be long term? I mean, maybe the shrubs will be abandoned for a few years and then it will change back to tundra. Well, shrub expansion has occurred in other environments like severe grassland and tall grass prairies. And shrub expansion in this environment does seem to persist almost to the point of causing a shift. Once it is established, shrubland thrives, particularly in the Arctic, because the Arctic shrubs are good at taking advantage of the nutrient soil better than other Arctic plants.